Nice to meet you all. It's really my great pleasure to have a lecture in front of you via this web seminar. Although the whole world is in chaos because of this pandemic, we cannot stop learning about new things regarding the revolution of digital dentistry. So, my title of this lecture is Digital Dentistry in 2020. Where do we stand on? So before starting the lecture, please let me introduce myself briefly. So I have studied dentistry in dental school in Korea, and I acquired my master's degree and PhD degrees in the same graduate school. And after that, I moved to University of Geneva in Switzerland as a research scholar. At that period, I had worked really into digital dentistry with Professor Zeiler, who is the editor-in-chief in the International Journal of Prosthodontics. Yes, she is. So I conducted many studies regarding digital dentistry analysis utilizing many scanners and several kinds of softwares with many colleagues there. So let me introduce a bit of life in Geneva. This is virtual vertical dimension augmentation and it's 3D analysis, kind of things. I would say in this era of digital dentistry, we got two kinds of freedom, really. We can store 3D surface data of model, which means that we don't need to store lots of store model anymore, like this. We can just store it with the file. And also, I performed a study regarding 3D bioprinting to generate 3D customized bone or bony defect area. Yes, this is something like this. There are many kinds of 3D printer actually. So I want to show you about from the past to present of digital dentistry. So it started 1950, almost 1960. CAD in dentistry. So, like this, as you see, in 1983, Professor François Duret, he was the first dental CAD system, and after that, CEREC system is the first chairside system, CAD/CAM system. And 90s and 20s, the CEREC was developed as CEREC 2 and CEREC 3 and InLab like that. And after that, 25, CEREC 3, there was a CEREC 3 3D virtual occlusal adjustment function. Yes. Let me show you. This movie is really the first moment of CAD/CAM dentistry. Really, this was the first intraoral scanner, and as you can see, it's really big and it was heavy. At that time, the CPU and computing power was not that good, so it was really slow. Yeah. And François Duret, he made a provisional crown using PMMA, and in this movie it fits well in this movie, but actually he said it doesn't fit at all. So these days, there are many systems and like 3-shape trios. These days really Trios 3 and 3-shape Trios 4 is the, I would say, world leading equipment as an intraoral scanner. And also Prime Scan of CEREC system is also very good. And so many scanners, as you know, like 2018 Medit i500 and Planmeca, something like that. So let me show you one of this study. This study reported that the deviation of 5 different intraoral scanner, and we think, is it really precise? Is it really enough to use in clinical work? So the deviation is only 15 to 30 micron according to 5 different intraoral scanner, and it is really, I think now it's really clinical acceptable. For single crown and for partial prosthesis like 3-unit bridge, the deviation is quite good. Actually, there are really lots of comparison study to evaluate the accuracy of intraoral scanner and conventional silicon impression. And mostly, they say that it is hard to find out the difference between intraoral scanner and conventional impression for single crown. However, for the full arch, in case of full arch, there seems to have to be improved further yet. So, but as you can see in this graph, intraoral scanner has a good result compared to polyvinyl siloxane. So the ISO reference, ISO for assessing of accuracy of distal impression is renewed last year. They will be really getting better to comparison the ability of each intraoral scanner. So let's see. Actually, this is the real surface of intraoral scanner as it is. There are so many small triangles, but usually we don't see like this kind of triangle. We just see really good looking 3D model. So we don't know about this 3 triangle format. Yes, I will explain another lecture about this, because clinicians also know about this kind of surface, how it is composed, how it was progressed. So what will be improved for the future? I think for CAD/CAM and for intraoral scanner, the artificial intelligence, it is the real important part. The point of improvement of distal scanner, the point of improvement of intraoral scanner is the user experience should be upgraded, really. And for that, the AI is really important. In clinic, we don't want to click the mouse very multi-click is not that good for clinician. We just click 1 or 2 click, and then we just want to get some good result. So for that, AI should be improved. And it's really developing these days. And stress analysis, this is so-called finite element analysis, and it was conducted only for research purpose. But I guess after like 4 years or 5 years, a common clinician, common dentist would be able to analyze of stress a bit in CAD software, I hope and I guess. And more advanced scanning, I will focus on the improvement of scanning later, and 3D printing and CAD software. So there would be many aspects to be improved in the future. And as we already know, we can easily find the innovation of intraoral scanner and many kinds of digital equipment in such as International Dental Show and many other dental exhibition, international dental exhibition. And the accuracy of our intraoral scanner is also gradually improving, and they are really huge improvement regarding user experience when using intraoral scanner. The speed and scanning flow is getting better and better every year, and so there are lots of improvement in digital dentistry every year, and it's impossible to deal with all of the contents in digital dentistry within 30 minutes. So let me focus on 2 things. let me focus on the development of intraoral scanner and innovation of software. I would focus on these two aspects. Lots of things have been improved now. However, there are still many points remain to be improved. I have used this new version of scanner, Virtual Vivo from Straumann recently. One of the interesting points, this scanner has gesture control function. The scanned 3D model is freely moved like just using one hand, like zoom out, zoom in, something like that, rotate and panning, and without touching screen. So as you know, when we treat patient, the clinician's rubber glove is easily contaminated from saliva and blood. After that, we should touch some screen or we should touch mouse. It's really annoying and uncomfortable when touch mouse or keyboard or screen. So from this aspect, this gesture control make us free from touch screen, keyboard or mouse. Beyond scanning the surface of tooth structure or surface of gingiva, the additional technology will help diagnosis of caries was introduced in Trios 4 3Shape. So it is new version. The infrared light source help to detect the easily caries under the surface. So we need to know the origin of source of light. As you can see, the wavelength of infrared light source is from 1 micron to 100 micron in this graph. And in distal dentistry, we use from 1 micron to 1.5 micron of light source, which is used for research. But I mean, usually for the surface scanning, we use the visible light, like blue light or something which has 500 nanometer of wavelengths. And we had used only this area of visible light, but the light, the electromagnetic wave has multiple waves actually, and visible light is only from 0.4 to 0.7 micrometer. So we need to know the infrared region. So here, this light can penetrate the surface, even the hard surface. And it can penetrate the soft tissue, like 2 millimeter or even 3 millimeter of gingiva. It can penetrate. So maybe after a few years, and I mean, this Trios 4 has two sources of light source, visible light source and infrared light source. And that infrared light source can penetrate the hard tissue of enamel or dentin, so it can help to detect the caries. And after a few years, I think we can just penetrate the gingiva to scan the subgingival margin or to scan the alveolar bone, where the effect is, where would the defect. Yes, I mean, it's really a key point of development of intraoral scanner. Many other companies try to integrate this infrared light source. So let me show you another figure. So here is classical optical microscopy, and this area is OCT area. So using the infrared light, we can penetrate the surface and we can get more and more good information for diagnosis. So there are many various spectrum of electromagnetic source for research use and medical use, and we don't need to use only visible light. We can use more and more another light source. within the one intraoral scanner. So this Trios 4 is really all-in-one, carries detect function using infrared light source and also visible light source to get the surface information. So scanning on the surface and scanning under the surface, like this day we can scan beyond 1 millimeter or even 1.5 millimeter of penetration of enamel and dentin. Now we can, the technology is developing like that. Someday it will be integrated in one scanner. So the OCT above I mentioned, it means optical coherence tomography. So maybe after like few years, maybe we don't need to take an X-ray or for standard X-ray. We just can see 2D image using X-ray to see the inside of bone or inside of tooth structure. But using this optical coherence tomography technology, we can see three-dimensional image of 1 millimeter or 3 millimeter, from 1 millimeter to 3 millimeter of penetration. So it's really, I think this technique is really cool. So it was the development and it was the innovation of the intraoral scanner aspect. And let me show the cutting edge concept of designing implant crown using the CAD software. So the title is Stress Minimization of Implant Crown using Automated Vector Analysis, like AVA software. Let me show you. So here is 3D model, and let's see whether the vector of load transmission has towards the center of platform or not. So wherever the load is applied, the direction of external force is perpendicular to the tangent of occlusal point. So this vector from the outer surface of Bucker functional cusp has lingually, a bit lingually, which would make rotational torque lingually. So this is fulcrum, and the lingual torque would occur, as you can see. And we can see the various direction of vector according to various position of occlusal contact points. Some vector seems favorable and the other seems unfavorable. So occlusal contact points located in this green area would result less torque or minimum torque than the other area. Actually, in this era of digital dentistry, we can do further more than usual. That means we can find out each vector from each occlusal contact point for every single crown, implant crown. So we can consider the 3D position of implant. We already know when we scan the scan body, we already know the three-dimensional position of implant platform. And we maybe consider when designing occlusal surface of implant crown, the relation between the occlusal surface and the position of implant platform can be considered, and I think it should be considered. So we can export 3D XYZ data and vector data from this 3D data. This means that after we finish the occlusal design in dental CAD software such as ExoCAD or something, we may calculate the mean vector from the multiple occlusal contact points automatically And we already know the 3D position of implant platform from this CAD-CAM abutment data. Therefore, we may know whether this mean vector has towards to center of platform or not, or has to outside of platform. If it has obviously outside, or obviously buccally, or obviously lingual side of platform, then we can redesign a bit. And once more, we can calculate, we can analyze the mean vector from occlusal surface. And from this process, we can decrease torque. So actually, for me and for maybe for all of you, we just scan or we just take an impression for single implant crown, and we send the data to the dental lab. And the dentist rarely design the occlusal design by themselves, or the dental technician design the implant crown, and we don't know about the design of crown. So just they design and they fabricate and they send to the implant crown to the clinic, and just we just perform occlusal adjustment and just set. So in this process, we need to know the importance of mean vector and torque of implant stress. So if we can analysis before fabricating the implant crown, then I think it really helpful. So let me show an example. In this case, I performed automated vector analysis, and first, this was the first version of occlusal design, and I think there is only 3 points of occlusal contact, and I analyzed this, and I found out that this mean vector, the direction of mean vector, is really buccally distorted. It's really the mean vector has buccally, and it seems to generate huge amount of torque and stress. So I redesigned a bit and analyzed once more. So I redesigned the occlusal surface, and you can see the difference of occlusal contact points. And I analyzed once more, and I found out the mean vector of the direction of vector is really has into the platform area now. And this was the third version of occlusal design. And now it is really the mean vector really towards to the center of platform, and there would be really less vector, less torque compared to the first version of occlusal design. So the contour of the implant crown is almost similar. This was from the left to right side, version 1, version 2, and version 3. It really looks really similar, but I only modified a bit of occlusal area, and it shows great change of mean vector of the occlusal point. So this concept can be used during design process using ExoCAD or 3Shape dental system or something. So before finalizing design in the CAD software, if this analyzing function is embedded, integrated to the dental CAD software, like ExoCAD, this would be really nice. This should be performed easily, just clicking one analysis click button in CAD software. And let me show you some trial version of this analysis software. It is not commercial, it's for research at this moment. So this is automated vector analysis, and after designing implant crown, software, crown, antagonist, and abutment files were imported in this software. And with just one click, it calculates the mean vector from the occlusion surface within 1 second. As I mentioned before, the stress value is greatly influenced by the direction of load, even they have same amount of occlusion load. So we can analyze the vector of occlusion contact area and calculate mean of them easily with just click one button. And if it is really embedded in exocad, it would be really easy to use, easy to analyze. So I think, of course, even with design, using this software, the implant crown based on the automated vector analysis, the occlusion contact point in the mouth wouldn't be the same in the CAD software, CAD design because of many various errors. However, at least it would be much better considering vector analysis during CAD software compared to without any vector analysis. So at least we may be informed to the goal of occlusion contact from the automated vector analysis, and it would help when we perform occlusion adjustment in intraoral condition. And when it is integrated to the dental CAD software, it would be much easier to utilize and when designing the crown. So I think this is where we stand on and where we are heading in 2020, the era of digital dentistry. So the intraoral scanner will be really promoted, really innovated to using various sources of light, as I mentioned, like infrared wavelengths, and software will be really greatly, I hope, improved furthermore. So yes, I want to tell you thank you for your attention, and yes, this is the end of the lecture. Thank you so much.